Hello, everyone. Good morning, good afternoon, good evening, depending on where you're joining us from. Welcome to this series on MI2, which stands for Machine Intelligence and Modern Infrastructure. This session is all about building event-driven apps with Google Cloud Functions. I'm pretty excited about this session because it brings best of electronics, IoT, and of course, cloud. So we have an interesting deep dive on how to connect the dots to deliver a solution that basically controls connected devices and smart bulbs. So what is MI2? So MI2 is a webinar series that focuses exclusively on the convergence of machine intelligence and modern infrastructure. I'm very passionate about this convergence where we bring in IoT with containers or AI with serverless. And this combination is going to be the foundation for all the modern applications that we're going to build. So every month, I bring you two webinars, one focused on intelligence, which primarily talks about AI, deep learning, machine learning, and IoT, and modern infrastructure, which is all about Kubernetes, Istio, Prometheus, and cloud native technologies. So if you're interested in attending the future webinars, please do sign up at mi2.live. And these videos are also uploaded on my YouTube channel. If you are watching this on YouTube, don't forget to subscribe to my channel. So let's get started. If you are attending this for the first time, my name is Janaki Ram. I'm a Google developer expert for IoT and Google Cloud Platform. Apart from this, I'm a Microsoft Regional Director, MVP, IBM Champion, and Intel Software Innovator for IoT. So let's get started. So what I'm going to walk you through is the definition of serverless computing, followed by a closer look at FaaS or functions as a service. And then we'll take a closer look at Google Cloud Functions along with the concepts and terminology. And then I have an exciting demo followed by a quick summary of what we have discussed so far. So before I go any further, I want to make sure that all of you are able to listen to this and watch this clearly. So I'm launching a poll. Do let me know by clicking on either a yes or no. If you feel the audio and video quality is good, let me know by clicking yes. Awesome. So looks like everyone is able to watch this with good audio and video quality. Fantastic. And one more poll, which is relevant for this talk, which is all about serverless platforms and especially functions as a service. So which of the following have you used? AWS Lambda, Azure Functions, GCF or Google Cloud Functions, IBM Cloud Functions based on Apache OpenWhisk or others? All right, there is a tie between Lambda and Google Cloud Functions. I'm not surprised. These two have been around for a long time, and Google Cloud Functions have also become generally available last year. So I'm going to have a series of sessions on FaaS, and this is the very first session where I'm going to introduce you to the core concepts. And then as we go along, we're going to do deep dive sessions, but this is the overview and delivering event-driven applications on Google Cloud Platform by connecting multiple services together. All right, so what is serverless computing? But before that, let's step back a little and let's evaluate various options through which we can run code in the cloud. Now, what I mean by running code in the cloud is every piece of code that you execute runs in a context. And today, when we look at cloud, the context, the runtime environments, and the execution context is predominantly IaaS, where we spin up VMs and SSH into it and do a git clone to get our code, and then we'll run that. So that's a very traditional way of running code in the cloud. And most of the workloads typically use IaaS as the context, as the environment for running code. And then we have PaaS. For example, Elastic Beanstalk, Azure App Services, and Google App Engine, where you don't need to spin up servers, bring your code and run it. Now, more recently, we have seen the proliferation of containers, and there is a new delivery model for executing code called CaaS, Containers as a Service. There we have Amazon's EKS, which is ECS for Kubernetes, Azure Kubernetes Service, and of course, my favorite, Google Kubernetes Engine. So these are Again, environments, execution engines that run code. And this is the third mechanism for us to bring our code and run it in the cloud. But there is a fourth wave that is hitting us. And going forward, a significant portion of applications will run beyond these three that we discussed. And of course, we're going to see a combination of environments that are working in tandem to deliver the functionality. For example, you may have SAP running in IaaS with an elastic front end running in PaaS with some business logic running as microservices inside CAS. And all of them belong to the same application and same line of business environment that we are deploying in the cloud. So it's not exclusive. It is not mutually exclusive, but they're all going to work together in making it happen. And now we have the emergence of serverless computing. So what exactly is serverless computing and what is the relationship between functions and serverless computing? Well, I want to debunk a myth. A lot of developers think functions as a service is serverless and serverless is functions as a service. Well, in reality, serverless computing is a delivery model. It is a paradigm to deliver cloud services to customers. And it is the fourth wave of bringing services to the cloud. Of course, you can run code, but remember, serverless computing may be beyond running your code. It could be how customers can consume cloud services. So if you take a look at the depiction here, in on-prem, you basically own and manage the entire stack from the networking gear to hardware to operating system to runtime and apps. And when you go to IaaS, you basically have network given by the cloud provider, hardware delivered by the cloud provider, OS partial, you still need to patch it and you still need to keep it up to date. But a large part of operating system is also managed by the cloud provider, but apps and runtime is your responsibility. Now, when it comes to serverless, everything remains the same, but you also get runtime. And this is how functions as a service execute. So your app is actually a collection of functions that gets deployed, on a variety of runtimes, and they are connected together as a set of microservices to deliver one application. Beyond running code and functions as a service, you have other serverless computing environments. For example, BigQuery, which is Google's data warehouse at scale, is also serverless. Why? Because we never got to provision servers. It's extremely transparent. And similarly, Amazon's Aurora is also evolving into a serverless database. Again, you never need to provision resources. And similarly, Azure's container instances, where you will just launch a container without dealing with a VM or a compute or a network or storage resource. You launch a container as if you are running it on your local machine, but behind the scenes, Azure will provision a VM and place your container inside that and exposes that to the public IP. So because you're not dealing with resource provisioning in all the three cases, BigQuery, Amazon's Aurora, and Azure's container instance, all of them fall under the serverless computing model. But one delivery model of serverless that is picking up a lot of momentum and the future of application development is functions as a service. So it's an exclusive compute service built on top of the serverless computing platform. Remember, serverless is a delivery model and FaaS is another delivery model that brings abstraction to serverless. So it's a layer on top of serverless. Though they are used synonymously, they are slightly different. So what qualifies to be called as a serverless computing environment? So the first thing is transparent resource provisioning. If you are spinning up a server or if you are launching a cluster, then it is not serverless. It is either IaaS or PaaS or CAS. Similarly, serverless computing deals with per second billing. You don't need to have long-term commitments. You don't need to have an hourly pricing, but typically this is based on a per second billing, and sometimes even the billing is based on invocation. For example, in functions as a service, the pricing model is not about running your code or just keeping it in the standby, but every time it gets invoked and every time it consumes the resources, only then you get billed for it. And then That is what is leading us into event-based execution, where your code doesn't run all the time. For example, inside a VM, you need to run, if you want to run Flask, for example, in Python environment, you got to launch the Flask server and keep it running and listen on a specific port. But if you port the same Flask application into a function, you don't need to keep it running all the time. The runtime will respond to an event and then automatically does a get, put, or post request that is coming to your function. And you don't need to run Flask or Django all the time. The function is just there. And when an event takes place, it gets invoked or it gets kicked off as a process. And that is what is called event-based execution. So to qualify for serverless computing, you need to have these three attributes: transparent resource provisioning, per second billing or invocation-based billing, or event-based execution. So these three will what will qualify a service to be serverless. So introducing Google Cloud Functions. This is a fairly new addition to Google Cloud Platform. The first was App Engine that started almost a decade ago. Then GCE, or Google Compute Engine, was launched almost 8 years ago. And Kubernetes Engine went live somewhere in 2014. And more recently, Google Cloud Functions became generally available, which will bring fast to Google Cloud Platform. It is an extension of App Engine, though you don't realize it. If you carefully observe the way Google has created the IAM roles and the way it has been designed, it is very obvious that Google Cloud Functions is built on top of App Engine, and most likely App Engine Flex, because there are custom runtimes and there are other environments that are brought to Google Cloud Functions. Again, this is undocumented, this is pure speculation, but looking at the model and looking at the architecture, it looks like it's an extension of App Engine. Currently, Google Cloud Function supports running code snippets programmed in Node.js 6, Node.js 8, Python, and Go runtimes. Node.js 6 is generally available, while the remaining are still in beta. Most of the operating systems running these runtimes are based on Debian 8, or Ubuntu 16.04. So you can actually dig into the details by spinning off a shell or forking a process and figuring out the operating system details. If you're running Node.js 6, you'll actually find that the underlying operating system is Debian, and for everything else like Python and Go, you'll actually notice you're running on top of an Ubuntu distribution. Google Cloud Function supports two types of execution. One is an interactive invocation, and the other one is a background execution. We'll take a look at both of them. So Google Cloud Functions is a serverless FaaS, functions as a service, which means it is always executed in response to an external event. So the use cases for FaaS are slightly different from rest of the compute environments. For example, if you have a cloud bucket in Google Cloud Storage, a storage bucket, every time you upload a text file, you want to convert that into a PDF and put it out in another bucket. So there are two ways of doing it. One is to create a cron job, which will periodically poll the bucket for new objects. And if it finds a new object, it basically pulls that into a GCE VM, runs a PDF converter, and verifies the checksum and integrity of the file, and then pushes it to another bucket, and maybe sends a Google Cloud messaging notification saying that the PDF is ready. Instead, you can also use event-driven execution, where Google Cloud Storage raises events every time a new object is added to the bucket. And that event can be intercepted in Google Cloud Function, and there you will execute the code to download the file to temporary storage, run the PDF converter, convert this to a PDF and push it back to another bucket, and then send a notification. Now, the beauty of the second approach is you're not polling, and this is event driven. Every time an external event happens, your code executes in response to that. And that is the fundamental philosophy of functions as a service. It's not a good idea to keep something running forever in FaaS. If you're trying to port applications that require to run all the time, such as polling an external WebSocket or polling an external queue. Functions as a service is not a good execution environment. You should consider other execution environments like CAS or PaaS or IaaS. So on that note, let me uh, compare and contrast code written and run inside GCF and GCE. The first one is request driven. Your code is not going to run all the time. It only gets executed when there is an event that triggers it. There is whereas on GCE you have the infrastructure rental, where you are basically paying per minute. Fixed OS, fixed language. Here, you SSH as root, and you take the steering. You do whatever you want. You are basically the root. This is completely managed. For example, you don't have a read-write file system except the temp directory, where you can store some arbitrary files. Whereas here, you can attach a persistent disk or an SSD and gain terabytes of storage access. Scaling is implicit. You don't know how many instances are currently run. If the same function is invoked multiple times by multiple external events, GCF automatically creates multiple instances, and it is pretty transparent, and nothing is shared between these instances. Whereas here, you are scaling either by creating an autoscaler that is either proactive or reactive. You can basically say that when the average CPU threshold of a managed instance group goes beyond a specific threshold, add more instances to the group or terminate older instances. So it is based on certain policies, whereas here you don't have the policy. It is completely managed by Google Cloud Platform. So in terms of terminology, there are only 4 things that you need to understand when it comes to GCF. The first thing is a function. A function is nothing but a code snippet with well-defined entry point and also an exit point. It's very important for you to write a function that does one thing and only one thing at a time with a very well-defined entry point and has a graceful exit. So you cannot, for example, hold a connection to the database forever, and that is not a graceful way of exiting the function. You should always terminate open connections to resources and have a very graceful exit. And well-defined entry, because you always expect that the external metadata is coming into the function as a set of well-defined parameters. For example, there is data and context through which you can introspect what triggered this event and what parameters are coming into the pipeline, into the function, and you can take action against that. So that is what is called as a well-defined entry point. And then you need to understand events. So events are raised by external cloud services in response to change in state. For example, adding a new storage, new object to the storage bucket, creating a new message in the queue, or modifying a row in the database. So all of them are resulting in change of state, and change of state raises an event. And events are independent of functions. Google Cloud Platform, or for that matter, mainstream public cloud platforms, are now increasingly becoming event-driven, which means every time you launch a resource, you terminate a resource, you manipulate a resource, there are events that are generated. It's up to you and the customer to intercept and trap those events and do something meaningful, or you can just ignore them. But irrespective of whether you consume or not, these events are always raised. Now, that is an event. Now, trigger is basically the mapping between an external event and the function. For example, there are 100 events that are taking place. There are 100 functions. They are autonomous, they are independent, they are completely living in their own world. But how do you connect a function to respond to a new upload to a storage bucket? You create a trigger. So trigger is the glue between an event and the function. Events are loosely coupled, functions are loosely coupled. They exist irrespective of the other resources and dependencies, but it is a trigger that actually enables a handshake between an event and a function. There is also a concept of background and foreground function. So foreground function is an interactive function that is invoked by HTTP. So you can almost think of it as a HTTP endpoint, like an API gateway or a webhook. You can hit that endpoint, and whatever you send as the request header body will be automatically become available to the cloud function. If you are using Node.js, you are actually going to get Express.js equivalent functionality where you can have access to request and response. If you are using Python, it uses a very similar architecture where you have access to request response streams. So whatever you send via HTTP will become available to the function. That is an interactive way of invoking a function. You can always put a CNAME and add a nice meaningful DNS name and use it in your microservices to treat it as a REST endpoint. But not every function needs to be interactive. Majority of the functions, most of the functions are going to be invoked in response to an external event, and those functions are called background functions. So that is it. What I absolutely like about Google Cloud Functions is its simplicity. If you understand this, you know most of the functionality and most of the concepts of Google Cloud Function. So this is how we visualize background functions and foreground or interactive functions. So an interactive function is directly invoked by a HTTP trigger. The moment you create a function and choose HTTP as a trigger, you get an endpoint, and you can use curl to basically hit that endpoint and your function will start responding. That is the easiest way. Or you could actually have an external resource like cloud storage or PubSub or an IoT sensor, and that raises an event, and that event will change the state of a cloud service, which will in turn trigger and invokes a function, and this is called background function. If you are running interactive functions, you have other choices. For example, I can very easily port an existing App Engine web server code to an interactive function. But if you have a cron job, or if you have a background job, or if you have something that is invoked in response to an event, then you should map it to a background function. And there are multiple mechanisms for you to invoke it directly and indirectly, and we'll take a closer look at it. So what are the available events and triggers? Well, you can invoke a function with HTTP, which is pretty straightforward. You can hit the endpoint and it results in the invocation. Cloud storage is another popular source where you add or delete an object from a bucket and it results in an event, and you can create a trigger to connect that event to your function. Cloud PubSub is a phenomenal channel for Google Cloud Functions because you can do fan out, you can do a lot of highly scalable, loosely coupled, message-driven application with the combination of Cloud PubSub and functions. And this is the preferred mechanism to build microservices and event-driven applications on Google Cloud Platform. Firestore and Firebase are predominantly meant for mobile developers. So if you are using Firebase as the mobile backend for your Android or iOS app, and every time you modify a document and you want to invoke a function, you can actually write some business logic and attach it to the Firebase document, and that gets executed in response to the change in the state of the document. It's almost like a database trigger, but happens at the document level for a NoSQL schema-less database. Stackdriver, which is Google Cloud's, and of course it also supports AWS. It's a monitoring, logging, and tracing environment. So you can connect Stackdriver to functions via PubSub. So basically, Stackdriver publishes to a PubSub topic, and that PubSub topic is connected to a function, and you can monitor changes to Stackdriver. So it's an indirect way, but technically you can still invoke functions in response to Stackdriver alerts. So enough of theory. I want to now walk you through a cool, simple demo, but very powerful in terms of the power that we can exploit. I'm not going to show you a simple interactive HTTP function. You can easily figure it out, but I want to show you a slightly sophisticated application that is more meaningful. So we'll connect a smart bulb to the cloud. I have a video stream here, so you can actually see I have a live smart bulb, and this smart bulb is connected to the cloud. And the goal is to create a PubSub topic and a cloud function which will switch on and switch off the bulb at predefined times. For example, I want the bulb to be switched off at 7 a.m. every morning and automatically switch on at 6 p.m. in the evening. Now, instead of running that cron job in my machine or spinning up a VM and running it, I want to connect multiple services to achieve it. Very inexpensive, the cheapest possible way. So we are going to create a cloud scheduler as a cron job. So I'm going to create two jobs, one to switch on the bulb and one to switch off the bulb. Basically, they publish a message to the pub/sub topic, and we connect the pub/sub topic to the cloud function, and cloud function simply invokes the Lifex bulb. Either it switches on or switches off. You might think if Lifex is exposing API, why can't I directly invoke it? Well, I want to take the approach of a fan out. For example, I may have multiple bulbs that I want to control in a different fashion, or I might want multiple applications to change the state of the bulb. For example, I want to build a mobile app where I can change the color of the bulb based on the music I'm playing. So when I invoke a music player on my phone, I can basically figure out the type of the music and then automatically set the color of the bulb. So you can do a lot of things when you go via the pub/sub topic instead of HTTP. So that is the use case, and let's get started. I want to show you this demo. And again, if you have been following this series, you know that every article has one or more articles associated with it. One article related to Google Cloud Functions I've already published at the New Stack last week, and tomorrow you'll actually see a step-by-step guide and the complete tutorial along with source code becoming available at the New Stack. Tomorrow at 4:30 p.m. India time, you'll have this article go live. I also uploaded the code to the gist on GitHub, so that is the short URL bit.ly/gc of Lifex. If you are watching this on YouTube, you can expand the details of the video and you'll find links to the article, to the code snippet, to the slides, and to the tutorial that I'm going to publish. So all of them will be made available as a part of the video. All right, so time for me to switch to the demo. So before that, let me bring my video stream onto this, onto the screen. So I'm going to put this here and switch to my terminal. All right, so let me keep the bulb in the foreground so that you can keep an eye on it. Always on top. I really love this utility. It's a mechanism for me to stream my iPhone camera to my desktop. I use a tool called Reflector, and this gives me a chance to basically stream the video camera straight from my iPhone to my desktop. So there we go. So here is the bulb. So now let me show you how to invoke this programmatically. So Lifex is the smart bulb vendor. What you see here is a Lifex bulb. I've been using it for almost 6 years now, and I absolutely love what they build. So it comes with a fairly straightforward API, and all you got to do is sign up with the developer zone and grab a token. And this token can be recycled. Right after the demo, I'm going to delete this token because I don't want you to operate my living room smart bulb. So once you have this token, you can basically do a very simple curl on the endpoint and you can control the bulb. So let's try this out. So now I'm going to power on my bulb programmatically. There we go. So here is the bulb glowing on with a very simple command, right? It's a curl endpoint. It's a REST endpoint invoked from curl. Nothing fancy. That is the beauty of connected devices. But the goal is to basically control this periodically, right? I don't want to leave this bulb running forever. So I want to switch it on in the evening and switch it off in the morning. So, oops, I should have disabled. I did. I don't know why I'm getting this. Okay, so now we have the code running, which is basically the CLI that we have used. So now let's actually connect the dots. The very first step that I'm going to do is to create a topic, right? And let me put this in the background. I don't want this to occupy screen space. All right. So now the flow is very simple. We are first going to create the topic in pub/sub. And this topic is the conduit. It is the channel for us to connect a variety of publishers to multiple subscribers. PubSub in itself doesn't have a clue what we're going to send. It is just a fan out mechanism where anything that gets dropped into the PubSub queue will automatically get delivered to all the subscribers. So this is the foundation, this is the heart and soul of our application. So we start by creating a topic under PubSub. That's it. You don't need to do anything beyond that, right? So we just created a new topic called Smart Bulb. Okay, here it is. So that's the only thing that you need to do. We don't need to manipulate any other settings. We don't even need to create a subscription. So now we have the PubSub topic in place, and I have a blank slate. I don't have any functions created in Google Cloud Platform. So I'm going to create a function now. So I click on create function. And then again, the philosophy of Google is to make it minimalistic, simplistic, yet powerful. So you don't have a lot of buttons and knobs and sliders. It is pretty straightforward, but it doesn't mean it is underwhelming, or it's not powerful enough. It is extremely powerful, but it is simple at the same time. So we are going to call this Smart Bulb, right? And you can change the memory allocation. So 256 MB is good enough. Trigger. So all these are the triggers that we talked about. HTTP for interactive invocation, PubSub for indirect, cloud storage for object-based invocation, FileStore for document-related ones, and Firebase and FileStore, all of them are meant for document-based invocation. So we choose Cloud PubSub, and then it enumerates all the topics, and I'm going to simply connect our function to the topic called Smart Bulb. What this really means is we are now connecting the dots between a PubSub topic and the function via the trigger. So it can't get simpler than this. Fantastic. Inline editor, absolutely. I want to code interactively. I don't want to upload. But if you have a package.json already created with all the dependencies, and you have an index.js, you can combine them into a zip file and upload it. Or you could put it up on the cloud storage bucket and put that location. If you are using cloud source repository for your source code, you can simply point GCF to that. Now, in our case, we're going to copy and paste code because we don't have many dependencies. We don't have custom libraries. So it makes sense to just use the inline editor. So runtime, Node.js, Node.js 8, Python, and Go. Again, I want to keep this simple. So Node.js 6 is good enough. Package.json, we're not going to touch this because I'm going to use the built-in HTTP object. It comes with Google Cloud Functions runtime. I don't need to add any other library, so I'm going to use the existing one. And now all I'm going to do is copy and paste my Node.js code. So here we have the code. It all starts with exports.bulb, and that is the entry point. And then we have two parameters coming into our function called event and callback. And we are more interested in the event, and callback is just to report back. It is like calling home and telling everything is fine. So we are more interested in event. So we basically start with the HTTPS module, and then we grab the data that is coming into the event parameter. And because it comes as base64 encoded, we go ahead and turn that into a string. And because we are using Node.js, this string is directly encoded into a JSON payload, which is very handy. So data ultimately contains a JSON payload that looks something like this. Let me show you. So we are going to have a JSON payload come into the function in this format. Power on, color, brightness, and so on. So that's the JSON payload that we get, and then we go ahead and build the options. So we are hitting api.lifex.com. It's a HTTPS, so 443 path, the URI, the method is put, and then we are basically populating the authorization token. We are using basic authentication, and then we go ahead and call the endpoint, and if there is no error, we basically log success and call home saying everything is done, and we close the stream by calling request.end. So pretty straightforward, 40 lines of code, and it does what we want to do. So let's go ahead and paste this in the text box. So it's an inline function that we are copying and pasting. Now I come to the last step. So function to execute is not hello pub/sub, but it is called bulb because we are exporting this module as bulb. So this is what is the entry point. So this is the function to execute. And if you want, you can configure other details, but I want to leave it with the defaults. Why do I think it is built on top of App Engine? Well, the service account is actually based on the App Engine default service account. So that actually gives away the fact that it is built on top of App Engine. If you want, you can add variables that you can control at runtime, but we don't need to tamper with any of this. All right, so that's it. Let's go ahead and click on create. This is going to take a minute. So now this is what is called transparent resource provisioning, which is the key trait of serverless computing. So behind the scenes, Google might be provisioning a VM, maybe creating a Docker container out of our code, or creating an App Engine Flex environment and pushing the Docker container inside. We don't know, and we don't need to know. So that is the beauty. And now the green checkbox indicates the function is active, and we're all set. Awesome. So now we have the subscription. So now if you actually do a refresh on the Cloud Pub/Sub, you'll actually see there is a subscription created, and this subscription is connected directly to the trigger. So this is the trigger which will invoke our function. But again, we don't need to create it. The moment you wire the function with the Pub/Sub event, the subscription is automatically created. All right. So now we are ready to test our application. 40 lines of code, just a couple of clicks here and there, and we have a full-fledged serverless application. So let me bring up my smart bulb. Okay, so how do I, okay, I wish I disabled this. Sorry about it. I disabled all alerts, but I don't know how I'm getting this. I hope I don't get any confidential mails while I'm presenting this. I don't have enough time to go ahead and disable my notifications. Or maybe I can. All right. It's already in do not disturb mode, so I shouldn't be technically getting any more notifications. All right. Sorry about it. So now what are we going to do? Well, instead of invoking the HTTP API of Lifex, I want to publish a payload to the Google Cloud Pub/Sub topic, which is called bulb, or maybe smart bulb. That's what was the name of the topic. So now we are going to simply publish a message to our topic called smart bulb. Now, the moment we drop this message to the queue, it triggers the function, and function will call the Lifex API, and the bulb should go off. Let's check this out. Cold start. Okay, so the first time you invoke, it's going to take a few seconds and the bulb is off. Now that is a good indicator that everything is in place. Let's go ahead and play with it a little bit. So I'm going to now turn it on. So when we actually publish this message called power on, this time it's going to be slightly faster. There we go. Now the bulb comes back. So this is an indirect way of invoking the API. Now, a variety of publishers can control our bulb. For example, I want to connect Stackdriver to my function, and when the average utilization of my managed instance group of GCE goes above 80%, I want the bulb color to be red. Wow, that is very interesting, right? Or when every time I get a tweet, where I mention I want to blink the bulb. So I monitor the Twitter stream, and every time that happens, I publish to the Pub/Sub queue the topic, and that invokes the bulb and blinks it twice. So lot of uses when you perform indirection via Cloud Pub Sub. Beyond powering it on and off, you can also do other interesting things. For example, I can now change the color of the bulb from yellow to blue. So in just a few seconds, it becomes blue. So a lot of interesting things can be done. All you got to do is change the payload and publish it to the queue. So you can also adjust the brightness. Again, all these are supported by the LifeX API. I'm not doing anything. I'm just using PubSub as a proxy, Google Cloud Functions as a proxy, and this payload goes all the way to LifeX API, just bypassing every entity that we have in the line, which is PubSub to functions to LifeX API. So now our bulb should become much brighter. So I turn this to brilliant. So now it has become yellow with brightness 1. So there is no limit. You can play with this forever. You can change some parameters and you can start publishing it, and it automatically changes. So very, very powerful mechanism. Now, what we need to do is to create a scheduler. So now what I want to do is I want to run this on a schedule. So what can we do? Well, recently, Google has launched Google Cloud Scheduler, which is currently in beta. It's a fully managed cron job where you can basically schedule a job, and this job can do a variety of things. It can hit a HTTP endpoint, it can drop a message to the PubSub topic, it can invoke a webhook. It's totally up to you on what you do with it. So now what we're going to do is we'll create 2 cron jobs as a part of Google Cloud Scheduler, one to switch on in the evening and one to switch off in the morning. So we're going to create this called bulb on, and we can actually use this. So this is a typical Unix cron style nomenclature. So 0, 18, 3 stars indicates that basically switch on this bulb at 6 o'clock every day. So if you're interested, you can learn more about the functions, particularly how you schedule your cron job. For example, the asterisks here indicate minute, hour, month, exactly like Unix cron job. So this basically tells the cron job to execute on every day at 6 p.m. You define the time zone, target PubSub App Engine HTTP. This is a private endpoint internal to GCP or an external webhook or a HTTP endpoint. So we choose PubSub. There is no drop down. Remember, this service is still in beta. So we populate this with smart bulb. Payload. Payload is pretty straightforward. So we'll say power on. That's all. That's the simple JSON payload that we'll pass at 6 p.m. every day, IST. That's it. So now we are going to create this job. It just takes a few seconds and we have a cron job that is scheduled. Now let's create another cron job, and I'm going to call this as bulb off. It is again PubSub, topic is smart bulb, payload is off. So simple. We want to switch off the bulb at 7 o'clock in the morning. So I don't want to make a mistake. I don't want any typo here. So this is 7 o'clock every day, India time. The bulb is going to be switched off. Now we'll go ahead and create this. Perfect. So now we have all the elements in place. 2 cron jobs to kick off the job via PubSub to the Cloud Function, all the way up to the LifeX API. So how do we test? Let's click on run now, and this should switch off the bulb. So if it is successful, then the bulb should go off. There we go. Okay, looks like, okay, so there has been a little bit of delay. So now the cron job has run, and what it really means is the entire chain has been executed. Now I'll go ahead and click on run now for bulb on, and that should bring the bulb back. So again, there's a little bit of delay and lag, but you notice that the bulb is now switched on. Fantastic. That's it. Now we have a fully fledged serverless application running, and 40 lines of code, couple of clicks here and there. and we have a full-fledged application. So a quick recap of what we did. Cron jobs, dropping a payload to PubSub topic, which will invoke the cloud function, which will in turn call the Smart Bulb API. So that's it. Now, this is, as I said, this is the intro session. Going forward, we'll see deeper dive sessions on cloud functions where I will actually walk you through various other parameters and how we can actually deploy polyglot microservices that talk to each other and how we compose an application just with cloud functions. So that was the demo, and as I promised, by tomorrow you have all the assets related to this session, and that brings us to the end. But before that, let me call out and thank my sponsors. So the new stack is the media sponsor. All the content of MI2 will show up at the new stack. The context, the concept articles, everything, the tutorials. So everything that I mentioned here will be available on the new stack. You can go back and look at the archives. You'll find almost every article and every theme that I presented at MI2. Foghorn is an edge computing company based in Mountain View, and they are the multi-cloud edge platform for delivering AI and analytics at the edge. Portworx is a container native Bay Area based company. They do storage, container native, cloud native storage for running production workloads on Kubernetes and Mesosphere. So before I move to the questions, I want to announce the next session. So I'm pretty interested in bringing to you the next session on the neural networks with Intel Movidius. So I'm going to show you how to take an existing model and optimize the graph for a faster inference based on what is called as Intel Movidius Vision Processing Unit or Neural Compute Stick. So this is an interesting topic where, again, I'll show you a live demo of connecting a vision processing unit to a Raspberry Pi and performing object detection using Intel Movidius at scale and at much higher FPS and faster inference cycles. So that's about the next session, and please do sign up at mi2.live. I'm going to update the landing page in a couple of hours, and you should be able to get an update, or you can go to mi2.live right away and sign up for the session on March 14th. So that brings us to the end of this session. I have a couple of polls while we are still at this. So how relevant was the webinar content? I really appreciate if you can take a second and tell me. Excellent. Majority of you found it to be highly relevant, which is very encouraging. And as I said, those of you who thought it could have been better, it's again meant for beginners, and I wanted to introduce the concept of fast through Google Cloud Functions. But if you have expected more deeper dive content, stay tuned. I'm going to bring it for you. One final poll, which is absolutely critical and important for me. How do you rate the overall quality of the webinar? This includes everything from my slide deck to the demos to the presentation content to my delivery style to the audio visual experience, everything. Brilliant. It's very encouraging to see this. Thank you so much for participating in these webinars. And for the last couple of sessions, I didn't have enough time for Q&A, so I couldn't really take questions. But today, I managed to finish it on time, and I am happy to take questions. So let me take a look at the question panel in the dashboard, and I'll try to respond to them. Okay, so there is a question on why serverless doesn't show up as a next layer of PaaS. Is it consumed on top of PaaS? Well, it is. There is no hard and fast rule that FaaS is built on top of PaaS. First of all, I want you to decouple these layers. In the initial days of cloud, all of us have seen a cake diagram, where there was IaaS at the bottom, PaaS at the middle, and SaaS at the top. But that doesn't hold any good. That model is completely broken, or it is shattered into pieces by the way we are dealing with IaaS, PaaS and SaaS, and of course CAS and FAS. So that architectural diagram of one stacked on top of each other is no more relevant. So technically FAS is an independent delivery model. It may or may not be an extension of PaaS, but very specific to Google Cloud Functions, as I mentioned, it does look like a logical extension of App Engine, which is a PaaS. Okay, how does GCF enforce security and what kind of an RBAC? Very good question. So GCF runs in the context of Google Cloud IAM. Basically, it assumes the service account role that you created for App Engine. So whatever App Engine has access to, your Cloud Function runtime assumes the same access. But if you want to make it very fine-grained and you want to restrict what resources and what permissions your function should have, you should create a new service account with a very fine-grained access control, generate a key, and use that instead of the standard App Engine context. So that will restrict the footprint of your Google Cloud Function and also gives you a very fine-grained approach to security. It doesn't use RBAC directly, but again, RBAC in a sense in GCP is IAM, where you create a service account and service account is tied to the resource. And in a lot of ways, it is the closest to think of as RBAC. And I also got this feedback that my Kubernetes webinars have been very useful. Thank you for that. I am committed to bring you high quality, useful content. And I'm very passionate about sharing what I learned. So I'm so glad that you like my demos and content. Okay, so there is a question by Naresh on raising an event when a SQL instance is turned off and turned on. How do I connect that to Cloud Function? Well, I don't have an instant answer. I'm not sure if Google Cloud SQL raises an event every time you launch an instance or terminate an instance. We need to check, but I'm not sure. But my gut feel is by using Stackflow, where you can actually get an audit trail for everything that you do within GCP. You can create a filter and an alert and feed that into a pub sub topic, and from pub sub topic you can feed it to a function, and that can raise an alert or execute some code in response to the Cloud SQL instance. Again, this is just my hunch or my educated guess. This may or may not be possible. All right, there are a lot of questions. I'm not sure if I can answer all of them. So there's a question on how does this compare and contrast with Lambda and Azure functions? Well, GCF is the youngest of all the three, and it is also ramping up. So purely on a feature perspective, GCF lacks quite a few features, but it is catching up fast. For example, Lambda has been around for more than 5 years, and that's the reason why they added a lot of functionality. Azure Functions, as a part of Web Jobs SDK and other forms, it has been there for a while. So Azure is also ramping up pretty fast. But Google Cloud Functions is the youngest of the FAS offerings, so it has some catch up to do. But nonetheless, it is stable, it is performant, and it actually works. It scales pretty well. So isn't triggering the serverless job via cron schedule going against the event-driven processing model? Not exactly. We are still using event-driven processing. We are not polling, remember. We are using cron as a publisher to the pub sub topic and function as a subscriber. So it doesn't matter whether you run the command line to trigger the event or a cron job does it for you. It is still event-driven. And if there are multiple jobs that are running parallelly, GCF will seamlessly scale. So it is not an anti-pattern. A cron job talking to a pub sub topic and the pub sub triggering an event driven function is a very valid pattern for executing functions. So it is not violating any of the standard norms. So how is the building done? Yeah, it is based on invocation. So again, as I mentioned, if you are not invoking the function and is just lying idle, you'll not be built. But if you are invoking it in a loop, for some reason you ended up writing a rogue cron job or an external function or an external event that is triggering the function umpteen number of times, and there are a lot of instances running in parallel, then you might actually end up seeing a pretty hefty bill. But if you are using well-defined event-driven model, you'll only be billed for the invocation. How to return a database commit response to HTTP trigger? No, not yet. There is no straightforward way of doing it. You can do it if your database is Firebase, but since you're talking about commit response, I assume you're talking about Cloud SQL. Nope, there is no straight mechanism for that. How do you handle exceptions in functions? So you have to basically test it thoroughly before you publish it in production. There is stack driver that will give you a lot of visibility into your function call trace. You're also expected to do a lot of console.log to make sure that you're writing the event chain and multiple stages of your function execution to stack driver. But if there is something fundamentally wrong, and if the function is crashing, you can see that in the console. It is pretty visible. And you can also do exponential back off, as in you need to implement retry policies, and after certain retries, you should gracefully exit. For example, if you are dependent on external API and it is taking forever, or if that API is invoked multiple times, you need to have some kind of a retry policy and break it at some point. Otherwise, your function will be running forever. Of course, the max execution time of Google Cloud Function is 9 minutes. Beyond that, it just terminates. But if it is a graceful termination, you might still have a lot of stray resources hanging around. So it's a good idea to track what you're actually doing from the function, put that in a retry pattern, and circuit break it when you hit the threshold. All right, the last question for the day. So how is ML and AI interlinked with serverless? Absolutely. So auto ML is the serverless mechanism of serverless. So in serverless functions, you bring your code and run in the cloud. Similarly, with auto ML, you bring in your data set, push a couple of buttons, and you have a fully trained model. So that is a serverless machine learning for you. So I'm going to do a session very soon on Google Cloud Auto ML Vision. And that's when I'll demonstrate how to use AI and ML in a serverless mode. So that brings us to the end of the session. Again, if you are interested in machine intelligence, my next topic is all about that. Accelerating performance of neural networks with Intel Movidius. Do sign up at mi2.live. Thanks so much for attending this series of webinars. If you're watching this on YouTube, don't forget to subscribe. I commit to deliver high quality content and bring cutting edge technologies to you in this channel. Thank you so much. Have a great week ahead.